Let's look at implementing a Boolean expression. Implementing a logic or Boolean expression is really quite simple. Here we'll show it by example. So we have a function f that's equal to this expression in 3 or 4 inputs, actually, a, b, c, and d. And the functions, the elementary functions or operations that are involved in this expression are just the anding, the oring, and the inverting. And so we can implement this using our and, or, and not gates. Now what we'll do is we look at the most outer the most outer operation, okay? We have 3 terms that we're going to OR together. Okay, and so that means that we need to have an OR gate here, and we have 1, 2, 3 inputs. 1, 2, 3 terms that will feed those 3 inputs. Then we look inside each of those terms. So for term 1, we have the product of A with B naught and with C. So that means we're going to have an AND gate. So this, I'll say this is 4, and this is going to be implemented here with this AND gate. And we're going to AND A and C and then the not B. So this gives us not B right here. For the second term, it's just ANDing A, B, and C. So that's straight up here. We got an AND gate, call this 5. So here's that AND gate. We're going to AND A, B, and C. For the last term, that's actually comprised of ANDing 2 terms. We have, let's say we'll call this 6. We'll call this 7. So here, this output is 6. And this output here is going to be 7. And those two are ANDed together in this AND gate here. And then the inputs for our 2 ORs are going to be C and D, and then D naught and E. And here we have an inversion of D to get D naught. So it's pretty straightforward. You start from the outside, the most outer operations, and move to the inside.